Good evening to one and all present here. So now we will be presenting the Arduino document 2. This document will be presented by me, Arka Das, Shreya Sharma, and Sulagna Bhattacharya. So now I will give it to Shreya to present.
So
Shreya,
good
please.
evening. So good evening. Once again, I am Shreya Sharma. Today I am going to present a presentation about Arduino. Change the slide, please. So chapter 1, Arduino overview. Arduino is a prototype platform based on an easy to use hardware and software. It consists of a circuit board which can be programmed and a ready-made software called Arduino IDE. Here IDE stands for Integrated Development Environment, which is used to write and upload the computer code to the physical world. Next. Now we will know the key features about Arduino. So first feature, Arduino boards are able to read analog or digital input signals from different sensors and turn it into an output such as activating a motor, turning LED on off, connect to the cloud and many other actions. Second feature, you can control your board functions by sending a set of instructions to the microcontroller on the board via Arduino IDE. Third, unlike most previous programmable circuit boards, Arduino does not need an extra piece of hardware, which is known as the programmer, in order to load a new code onto the board. Next. Fourth, additionally, the Arduino IDE uses a simplified version of C++, making it easier to learn to program. Fifth, finally, Arduino provides a standard form factor that breaks the functions of the microcontroller into a more accessible package. Next. Now board types. Various kinds of Arduino boards are available depending on different microcontrollers used. However, all Arduino boards have one thing in common. They are programmed through the Arduino IDE. The differences are based on the number of inputs and outputs, speed, operating voltage, form factor, etc. Some boards are designed to be embedded and have no programming interface, which you would need to buy separately. Some can run directly from a 3.7-volt battery, others need at least 5-volt battery. Next. Now here are some list of Arduino boards based on Atmega 328 microcontroller. So first board name is Arduino Uno R3, whose operating volt is 5 volt. Clock speed. Here clock speed is same as the frequency of CPU clock, and the CPU clock measures the number of cycles your CPU is executing per second, which is 16 megahertz, and digital IO is 14. Analog input is 6. PWM, which stands for pulse width modulation, is 6. UART, which stands for universal isochronous receiver transmitter, is 1. And programming interface is USB via Atmega 16U2. Second is Arduino Uno R3 SMD, whose operating volt is 5 volt. Clock speed is 16 megahertz. Digital IO is 14. Analog input is 6, PWM is 6, UART is 1, and programming interface is USB via Atmega 16U2. Now here are some more board name like Redboard, Arduino Pro 5 volt by 16 megahertz, Arduino Mini 05, and etc. Next. Now Arduino boards based on Atmega 32U4 microcontroller, which are Arduino Leonardo, whose operating volt is 5 volt, clock speed is 16 MHz, digital I/O is 20, analog inputs is 12, PWM is 7, UART is 1, programming interface is native USB. Pro Micro 5 volt by 16 MHz is one of the board name, whose operating volt is 5 volt, clock speed is 16 MHz, digital I/O is 14, analog inputs is 6, PWM is also 6, and UART 1, programming interface is native USB. More are there like Pro Micro 3.3 volt by 8 MHz, LilyPad Arduino USB. Next. Now Arduino boards based on Atmega 2560 microcontroller. Board name Arduino Mega 2560R3, whose operating volt is 5 volt, clock speed is 16 MHz, digital I/O is 54, analog inputs is 16, PWM is 14, UART is 4, programming interface is USB via Atmega 16U2. Mega Pro 3.3 volt, operating volt is 3.5 volt, clock speed is 8 MHz, digital I/O is 54, analog inputs is 16, PWM is 14, UART 4, and programming interface is FTDI compatible header. More are there like Mega Pro 5 volt and Mega Pro Mini 3.3 volt. Now Arduino board based on 8091SAM 3x83 microcontroller. There is one only, which is Arduino Duo. Operating volt is 3.3 volt, clock speed is 84 MHz, digital I/O is 54, analog inputs is 12, PWM is 12, UART is 4, programming interface is USB native. Next. Now I will request Sulagna to continue this PPT.
Good evening to one and all present here. Now I, Sulagna Bhattacharya of class 8 RPRI, going to present the next part of the presentation, that is the Arduino board description. Here in the picture we can see that the board picture of the Arduino board is shown with all its part marked, and I am going to explain one by one all its part. Next. So the Arduino board consists of different components. These are the power PCB. The main function of it is helping the Arduino in powering. Here in the picture it is shown in mark part 1, and here the Arduino is powered by using the USB cable from the computer. All we need to do is to connect the USB cable to the USB connection. Power barrel jack. It is a cylindrical jack which is shown in the picture in mark part 2, and its main function is to power the board, and here the board can be powered directly from the AC main power supply by connecting it to the barrel jack. Next. Voltage regulator. The main function of it is to regulate or control the voltage that is given to the Arduino board and stabilize the DC voltage used by the processor and the other elements. It is shown in the picture in the part 3. Next. The crystal oscillator. Its main function is helping the Arduino in dealing with the time issue by creating an electrical signal with a constant frequency. Here in the picture it is shown in the part 4. The number printed on the top of the Arduino crystal is 16.000H9H. It tells that the frequency is 16 million Hz or 16 megahertz. Next. Arduino reset. Using this, we can reset the Arduino board. That is, we can start the programming from the beginning. The restarting can be done in two ways. Here in the picture, it is shown in mark part 17 and in 5. In the first part, we can use the reset button that is on the 17, and second, we can connect an external reset button to the Arduino pin labeled reset, which is shown in mark part 5. Pins 3.3, 5 GND and pin win. 3.3 volt, which is shown in marked part 6. Supply 3.3 output voltage, 5 volt, which is shown in marked part 7. It supplies 5 output voltage. Most of the components used in the Arduino board works fine with 3.3 volt and 5 volt. GND, that is the ground. There are several GND pins on the board, and any of which we can use to ground our circuit. Win, which is shown at marked part 9. It serves the same purpose as barrel jack, that is, it is used to power the Arduino board from an external power source like AC main power supply. Analog pins. The Arduino UNO has 5 analog pins starting from A0 to A5. Its main function is to read the analog sensor connected to it, like the humidity sensor, temperature sensor, etc., and convert it into digital values that can be read by the microprocessor. It is shown in mark bar 10. Next. The main microcontroller. It is the very important part of the Arduino board as it is the brain of the board. Each Arduino board consists of its own microcontroller. It is shown in the picture in the part 11, and the main integrated circuit in it is slightly different from the board. Is slightly different from board to board. The microcontroller are usually of ATMEL company. ICSP pin. Its full form is in-circuit serial programming pin. In the picture, it is shown in number 12. It is a teeny programming header which is used used as a method of programming the microcontroller. It is a header for the Arduino consisting of MOSI, that is master in slave out, master out slave in, reset VCC, serial clock, GND, ground, etc. It is often referred to as SPI, that is Serial Peripheral Interface, because it is a synchronous serial data protocol used by the microcontroller for communicating with one or more peripheral device, which could be considered as an expansion of the output. TX and RX LEDs. They appears in two places in our board. In the picture, it is shown in number 14 and also in digital pin 0 and 1. In 0 and 1, it is shown to indicate the pin responsible for serial communication. The TX LED flashes with different speed while sending the data, serial data, and the speed of flashing depends on the baud rate used by the board. RX flashes during the receiving process. Next. Digital input output. Here in the picture, it is shown in part 15. The digital input output in the Arduino UNO board, there are 14 digital input output pins, and out of which 6 provide PWM, that is pulse width modulation. It is the method of reducing the average power delivered by the electrical signals. The input digital pin read the logical values 0 and 1, and output digital pin writes different modules like LEDs, relays, etc. AREF. AREF stands for analog reference. It is sometimes used to set an external reference voltage between 0 volt to 5 volt as an upper limit for the analog pin. Its main function is to feed the Arduino a reference voltage from the external power supply. Thank you. Now I would hand over to Prava for presenting the next part.
Good evening to everyone present here. So now I am going to present the chapter 3 of the Arduino installation. So in this section we will learn in easy steps how to set up the Arduino IDE in our computer and prepare the board to receive program via USB cable. The following are the steps. Step 1. First of all, we have to choose our Arduino board and a USB cable. In case we have Arduino UNO, Lumen Nano, Omega 2560 or Decimedia, we need a standard USB cable, that is a A plug to B plug cable, and the kind we would connect to a USB printer as shown in the following picture. You can see the picture of the A plug to B plug USB cable, and this is the A plug to mini B plug USB cable. So next comes the step 2. Step 2 is for downloading the Arduino IDE software. You can get different versions of this software, but we should always download it from the Arduino official website. So which must be compatible with the operating systems like Windows, iOS or Linux. After the file is downloaded, we have to unzip the file. So here is the window for unzipping the file. We have to open the file, save it and click OK. The next is the step 3. We have to power up our board. The Arduino Uno Mega, Duomilanov and Arduino Nano automatically draws power from either the USB connection to the computer or an external power supply. But if we are using an Arduino Decimilia, we have to make sure that the board is configured to draw power from the USB connection. The power source is selected within a jumper and a small piece of plastic that fits onto two of the three pins between the USB and the power jacks. Makes that it is on the two pins closest to the USB port. Last of all, you have to connect the Arduino board to our computer using the USB cable. The on-board power LED, that is the green power LED labeled as PWR, should glow. If it does not glow, that means the connection is wrong. Step 4. After launch the Arduino IDE. After the Arduino IDE software is downloaded, we need to unzip the folder. Inside the folder, we can find the application icon with an infinity label. As shown in the figure, you can see the Arduino application with the infinity label plus and minus. Where we double click the icon to start the IDE. Step 5. We have to open our first project. So once the software starts, we have two options in our hand. First, we can create a new project, means we can type our sketch and program manually if we know the coding very well. To create a new project, we have to select file then new, or else if we do not know the programming well, then we can open an existing project as example. To open the existing project, we have to select file, example, basics, and then bring. So here you can see how to do the steps. This is the continuation of the step 5.
Continue.
So this is the continuation of the step 5. So in step 5, we are selecting just one of the examples with the name ping. It turns the LED on and off with some time delay or means the delaying time. And we can choose the example from the list. And the step 6 is to avoid any error while uploading the program. Means we must check the connection for the required Arduino board. The Arduino USB cable and software must be ready. For this, we must select Arduino board name that matches the board connected to the computer. For this, we have to go to the tools and board and then select the particular Arduino board in which we have to, if we want to program the sketch. This is the picture of the step, and this is the final step for programming the Arduino. Thank you. So if anyone has any doubt, can ask.
Yeah, doubt session is open.